Hello, my name is Arslan. I am a data science expert. If you need any help from me, please check the email ID. Please subscribe the channel and press bell icon. I will upload too many solved programs here. I'd be happy to explain the code you've provided step by step. Firstly, you need to make a CSV file with columns latitude, longitude, address, image _URL. If you are using Jupyter Notebook, then save this file into the home directly and then go to the file. In first section, you need to import necessary libraries and modules. Here's what each library does. You can install all libraries with Jupyter Notebook with using pip install library name. CV2, OpenCV, a popular computer vision library, is used for image processing and computer vision tasks. Torch, PyTorch, a deep learning framework, is used for running deep neural networks and model inference. Torch Vision, this is a PyTorch library that provides various computer vision tasks and pre-trained models. FasterRCnet50_FPN, this is a pre-trained faster RCNN model provided by PyTorch's Torch Vision library. Faster RCNN is an object detection model. Functional as F, here, an alias F is created for the functional module of Torch Vision. Transforms. #load a pre-trained faster RCNN model. Model equals FasterRCnet50_FPN, pretrained equals true. Model.eval. In this part, you load a pre-trained faster RCNN model. The model is pre-trained on a large dataset and is capable of detecting objects in images. You set the model to evaluation mode with model.eval. #read the Excel sheet with image file names and coordinates. Data equals pd read _Excel, image _YOLO.xlsx. #define a confidence threshold. CONF_threshold equals 0.6. This threshold is used later to filter out object detection results with lower confidence scores. For index, row in data.iter rows. You start a loop to iterate through the rows of the data frame, where each row represents information about an image. Inside the loop, you extract information about the latitude, longitude, address, and image file name from the current row of the data frame. #load the image from the image file name. If image is none, print F error loading the image for address. You load the image from the specified image file name using OpenCV, cv2.imred. If the image loading fails, i.e., image is none, you print an error message indicating which image couldn't be loaded and continue to the next row in the loop. #convert the image to a PyTorch tensor. img_tensor equals f.to_tensor, image.unsqueeze, 0. You convert the loaded image, in NumPy format, to a PyTorch tensor using the f.to_tensor function from the functional module. With torch.no_grad. Prediction equals model, img_tensor. Here, you use the pre-trained faster RCNN model to perform object detection on the image. The model takes the image tensor, img_tensor, and returns a prediction, which contains information about detected objects. #filter predictions based on confidence threshold. You extract the detected bounding boxes from the prediction based on the confidence threshold, CONF_threshold. The prediction is a list of dictionaries, and you access the first dictionary with 0. Within this dictionary, you get the boxes and scores entries. You filter out the boxes where the scores are above the confidence threshold. If len, boxes, 0. Here, you check if any boxes were detected based on the confidence threshold. If there are boxes, you proceed to display them. Hashtag draw bounding boxes on the image. For box in boxes. X, Y, X2, Y2 equals box.tallest. CV2.rectangle, image, int, X, int, Y, int, X2, int, Y2, 0, 255, 0, 2. For each detected box, you extract the coordinates and use OpenCV, CV2.rectangle, to draw a green rectangle on the image. This visualizes the detected objects. Hashtag display the image with bounding boxes. CV2.imshow, detected entrances, image. CV2.waitKey, 0. CV2.destroy all windows. You display the image with bounding boxes using OpenCV2.imshow. Else. Print, F no entrance.